Okay, so this is a review for the test. So I'm going to do a little bit of everything. I'm going to do some radicals, some exponents, adding and subtracting, and some complex fractions. So the first one is what we just learned yesterday. It's going to have some square roots. So I have 1 minus the square root of 3 squared. So I want you to simplify this. So remember, when you see that exponent of 2, we're going to write it twice, and we're foiling here. So again, I'm foiling here. So I'm going to do first, 1 times 1 is 1. Then I'm going to do outside, 1 times negative radical 3. Then I'm going to do inside, negative 1 radical 3. And then last. Remember, whenever you multiply a radical by itself, the radical just disappears. And I'm doing negative times a negative. Now, on the blue and the green answer that I wrote there, technically I don't need to write that as 1 radical 3, but the reason why I did that is because when I go to group these middle terms, remember, treat the radical like a variable. So really it's negative 1 minus 1. So this, when I group the outer and the inner, it becomes negative 2 square root 3. Now let me just drop down the 1 and the plus 3. Now I can also add up these the constants, and then I could get 4 minus 2 radical 3. So again, write it twice and FOIL it. And I'm just going to start. Again, we're going to write it twice. So 2 plus square root 5, 2 plus square root 5. First gives me 4. Outside gives me 2 radical 5. Inside gives me 2 radical 5. And last gives me 5. So again, I can group my middle, and I get 4 square root 5. And then I can also add the 2 constants. So here I would get 9 plus 4 square root 5. You could also have written your answer as 4 square root 5 plus 9. It doesn't matter the order. All right, so this is when you're given a binomial squared. Again, you write it twice and FOIL it. Okay, let's try to do a radical like this. So number 3, square root of 5 over the square root of 2. What do I need to do to this problem?
Multiply by the reciprocal?
Nope. Good. I need to rationalize. So I need to get rid of that square root in the denominator. So I'm going to multiply both the numerator and the denominator by the square root of 2. So then again, remember, you can multiply inside a radical with inside a radical. So 5 times 2 is square root of 10. And again, whenever you multiply a radical by itself, the radical just disappears. Technically, I could do 2 times 2, which is 4, and then square root it. But again, don't worry about multiplying it. Just make the radical disappear. Now, I cannot simplify anything here because the 2 is outside the square root symbol and the 10 is in. So I am done. Let's try another one. Number 4. I have the square root of 35 over the square root of 7. Simplify this. Now remember, you can simplify something under a radical with something under a radical. You just can't do outside with an inside. So technically here, you might be tempted to multiply the top and the bottom by square root 7. but it's a lot easier if you just simplify the fraction first. I can divide 35 by 7, make it a 5, make the 7 square root 1. So now I have square root 5 over square root 1. The square root of 1 is 1. So my answer here is just square root 5. Now I could have gone through the process and multiplied by the radical 7, but then I would have had to break down that radical. So it's a lot easier to do it this way. Next one, number 5. Another one with radicals in a fraction. So the square root of 27 over the square root of 15. So again, you can simplify that fraction first because both numbers are under the square root. And then if there's still a radical left behind, then that's when we'll rationalize. So I'm going to divide them both by 3 and leave behind a 9 and a 5. So now I have the square root of 9 over the square root of 5. I can also figure out what the square root of 9 is, and that's a 3. But again, we can never, ever leave a radical on the bottom. It's illegal. We need to multiply the top and the bottom by that square root of 5 to rationalize. So this becomes 3 square root 5 over 5. I can't simplify the 5s because one 5 is inside the square root and the other one is outside the square root. So this is my simplified answer. So for number 6, we're going to have a number outside the radical. 27 is inside, and the square root of 63 is in the denominator. So again, try to simplify it first. I can divide them both by 9. So if I divide them both by 9, this becomes a 7, this becomes a 3. So now it's a little bit smaller to simplify. Again, I still need to rationalize here. So again, I'm going to multiply the numerator and the denominator by the square root of 7. Again, you multiply inside radicals, inside the radicals, so the 3 is outside. The 7 and the 3 are inside, so I would get the square root of 21. And then again, the 7 in the denominator comes out. And you're done. Again, I can't simplify the 21 and the 7 because the 7 is outside the square root. All right, we're going to try what was on the quiz, adding and subtracting. So we're going to add these fractions. So this is an example of what you did on the quiz. It's also on the test. So x squared plus 1 over x squared minus 1 plus 1 over x plus 1 plus 1 over x minus 1. When I go to add fractions, I need to factor first the denominators. So this denominator here can be factored. It is the difference of two squares, and it becomes x plus 1, x minus 1. Remember, when you find a common denominator, everything needs to be represented. So my common denominator is going to have an x plus 1 and an x minus 1. And I'm going to write this for all three fractions. And then I'm going to go back and fix my numerators. So as you can see, the first fraction is good to go. It has everything it needs, so I'm just going to rewrite the same numerator. Let me put the original numerators here. Now, the second fraction, however, Notice it's got the x plus 1, but it's missing the x minus 1. So whatever you're going to multiply to get to the common denominator for the bottom, you do to the top. The last fraction, it's missing the x plus 1. So again, whatever you're going to multiply to get to the common denominator to the denominator, do to the numerator. Now, common mistake that people are going to make right here is they think they could start canceling things. You must add the numerators first. So I'm going to go through. Now, if this blue one was a different number, I would need to distribute it. But because it's 1 times that, I'm just going to rewrite it. So my new numerator, I'm writing the first numerator from the first fraction, then the second one, and then the third one. Now remember, they all have the common denominator now. Now I need to go back and add my like terms. So notice you have an x squared here with nothing to add to it. Then you have an x and another x. So this would give you 2x. And then I'm going to go back and get my constants. 1 minus 1 is 0. Plus 1 again is plus 1. I still have the same denominator, x plus 1, x minus 1. Now, what happened to a lot of people on the test is a lot of people would have stopped right here. Okay? However, if that numerator can still be factored to get something to cancel in the denominator, we need to do that. And I can factor that trinomial because I can find factors of 1 that give me 2, and that's going to be 1 times 1. So my numerator will factor into x plus 1 times x plus 1. The denominator is still the same. And now I can simplify and cancel the x plus 1s. So final answer here is x plus 1 over x minus 1. So number 8, and that one's going to be x squared minus 4 over x divided by x minus 4. So again, remember, this fraction bar right here means division. So really what I'm doing here is x squared minus 4 over x divided by x minus 4 over 1. I need to do my keep flip change here. I'm going to also factor this guy. I'm going to turn this into x plus 2 and x minus 2 over x, flip it to the reciprocal, and now notice there is nothing that factors or cancels. So x minus 2, and then I could leave this like this. So just multiply now straight across. Nothing cancels. You don't need to FOIL it. You can leave it just like that. Nine is an exponent question. And I have 3 over 2 raised to the negative 2 power. So here, we're thinking reciprocal when you see a negative exponent. So I'm going to flip my fraction upside down, make my exponent positive, and now figure out what 2/3 squared is, which would give me 4/9. So you could do it like this, or you could also say it's really 2/3 times 2/3. Either way, final answer 4/9. Yeah,
So the 5 letters, keep your answer at 4/9, right?
correct. Number 10, another exponent question. 4x to the negative 3 over 16y to the negative 4. Remember, to make exponents positive, I'm going to flip their spots. So I can also simplify the 4/16. My 4 over 16 is going to simplify to 1/4. To make my x exponents positive, I'm going to write it in the denominator. To make my y exponent positive, I'm going to move it to the top. So my final answer here, you could leave it like that or just don't write the 1, and it's 4x to the 3rd. Remember, on this x, the negative 3 exponent is only on the x. It's not on the 4. And for the y, it's only on the y, not on the 16. Let's try number 11. 11 is 16 raised to the 3/2 power. When you have a fraction exponent, the denominator is the root and the numerator is the exponent. So really what I'm doing here is the square root of 16, getting that answer, and then cubing it. So the square root of 16 is 4, and then 4 to the 3rd power is 64. All right, next one. Number 12. 27 to the negative 4/3 power. Remember, a negative exponent makes it a fraction. Think reciprocal. So we're going to move this whole thing underneath a 1 and make the exponent positive. Now, I'm going to do the cube root of 27 and then raise the answer to the 4th power. So the cube root of 27 is 3, and then I take 3 to the 4th power, and I get 81. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. Next one. Radicals. Here with radicals again. So I have 5 times the radical 7 over 56. Again, I'm going to try to simplify my radical first instead of trying to rationalize this with the square root of 56. So I could simplify this, make this a 1, make this an 8. So now I have 5 over the square root of 8. Now, let me show you a cool trick. Now, technically what we should be doing here is I would break down the 8 first, okay? Because again, your goal is to make that a perfect square. What's the nearest perfect square? If I multiply it by 8, I'm going to get 64. But then I'm going to get a fraction that I got to reduce. Does that make sense? So let's break down the square root of 8 first. So the square root of 8 is going to be 4 times 2. And then it'll become 2 radical 2. Everybody with me on that? The easier way to do it is just to multiply the top and the bottom by square root 2. And then it'll become square root 16. But let's just break this down first. Let's make this 5 over 2 radical 2. And now to rationalize it, I'm just going to multiply it by the square root of 2. So then this would become 5 square root 2 over this 2 times this 2, the pair. So then this final answer is 5 square root 2 over 4. Now, we could have done this. We could have done rationalize it by multiplying by radical 8, and then you get 5 radical 8 over 8, but then you still have to go back and break down the 8. So then I could do that. Again, we just saw that this is going to become a 2 radical 2 over 8, and then I would get 10 radical 2 over 8, and then I still have to simplify it to the same thing I got there. So more than one way to do it. Another way, you could have realized that my goal here is to turn this square root 8 into a perfect square. So really, I could have just gotten it to a perfect square by multiplying it by 2. So then it became the square root of 16, and then I just square root it. And I still got the same answer that way also. So again, more than one way to go about doing that question. All right, next one, more exponents. So x squared, y to the negative 2 raised to the second power, x to the negative 1, y to the third raised to the negative 2 power. First thing I'm going to do is take care of the power to the power. Remember, when you have an exponent raised to an exponent, we multiply them. So I'm going to go ahead and multiply 2 times 2, get x to the fourth. 2 times negative 2 gives me y to the negative fourth. Then 2 times negative 1 gives me positive 2. And 2 times 3 gives me negative 6. Now, when you multiply powers that have the same base, we add their exponents. So I'm going to add x to the 4 plus x squared and get x to the 6th. And then I'll go back and get the y's. So y to the negative 4 plus negative 6 gives me y to the negative 10th. Now the instructions are going to say, leave your answer with positive exponents. So the only thing I need to do here is keep the x to the 6th on the top, but move the y to the 10th to the denominator. Pretty good. Now you could have also, at this step here, moved these the negative exponents to the bottom of the fraction and multiplied it that way also. So like, for example, right here, I could have taken this and set it up as x to the 4th over y to the 4th, and then this one times x squared, and then move the 6 to the bottom, and then just multiply straight across and still get the same answer. So again, different ways to handle these negative exponents. Let's try another one where we're going to break down a radical. So we have the square root of 63 plus the square root of 700. So again, remember to add radicals, treat them like variables. So let's break these down. This 63, I'm going to break down to 9 times 7. 9's a perfect square. I'm just going to square root it. The 700, I'm going to break mine into 7 times 100. I can see that the 100 is a perfect square and the 7 is not. So I'm going to get 10 square root 7. I now have like radicals, so I can just add the coefficients. So 13 square root 7. Let's do one where we have to multiply by the conjugate. So for this one, we have 3 plus the square root of 2 divided by 1 minus the square root of 3. Remember, we can't leave radicals in the bottom, so I need to rationalize this by multiplying it by its conjugate. And we did this the last 2 examples yesterday. The conjugate is the same number as that's in the denominator, but with an opposite sign. I now need to do 2 FOIL problems. I need to FOIL the top and the bottom. Now remember, for the denominator, all you need to do is first and last. The outer and the inner in the denominator are going to cancel. So for my denominator, I'm going to get 1 minus 3. So my denominator is going to be a negative 2. However, my numerator, I need to FOIL this thing. So I'm going to do first, and I get 3. I'm going to do outside and get 3 radical 3. Inside, I'm going to get 1 radical 2. And last gives me radical 6. Notice I do not have any like radicals. There are no like terms here, so I'm just going to rewrite this whole thing. 3 plus 3 square root 3 plus square root 2 plus square root 6 all over negative 2. There was nothing I could simplify. Okay, generally the outer and the inner would be able to be simplified, and even first and last. But in this case, because the radicals were different, nothing simplifies. Okay, 2 fraction exponents, and we're done. So number 18, I have x to the 1/3.
Pardon the interruption, but Curvin, Pierre, to support student services, Curvin.
Okay, so remember again, when you have the same base, you're going to take those exponents and add them. So 1/3 plus 2/3 gives me 3 over 3. 3 over 3 is 1 whole, so my answer is just x. And the last one, again, another exponent. So I'm going to do 5 to the 1/2 power times 5 to the 3/2 power. Again, I'm going to add the exponents. 1/2 plus 3/2 gives me 5 to the 4/2. Divide the 4 by 2. I get 5 squared. Final answer, 25. And I'm done. This is what your test looks like. So again, you will have adding and subtracting, complex fractions, the exponents, and the radicals. There will be a test review posted today before 2:30 for those of you who want to start on it, but your homework tonight is that exponent worksheet.